Okay, get this. What if you could speed up scientific discovery by 4,000 times? That is not a typo. Today we're talking about something called PhysicsNeMo. It's a new AI framework from NVIDIA, and it's doing way more than just making things faster. It's actually teaching AI the fundamental laws of our universe. So let's dive in.
So that really brings us to the core question, right? I mean, we've all seen AI learn to spot cats in photos after you show it millions of examples. But how do you teach it something way more profound, like the laws of motion or fluid dynamics? How do you get an AI to actually understand the why behind things, not just recognize a pattern? Well, that's exactly the huge challenge NVIDIA decided to take on. Now, to really get why this is such a game changer, you have to understand a huge problem that scientists and engineers have been stuck on for decades, really. It's called the simulation challenge. Just think about it for a second. Pretty much every major breakthrough, from designing a fuel-efficient jet engine to predicting the path of a hurricane, relies on simulation. It's how we build a digital twin of the real world to test thousands of different scenarios, saving billions of dollars and years of work. It is, no joke, an essential pillar of modern innovation.
Okay, but here's the bottleneck, the big problem. Traditional simulations, they are painfully slow. I mean, we're talking about a single complex simulation tying up a massive supercomputer for weeks, maybe even months. That costs a fortune, and it's a huge roadblock for innovation. The dream has always been to get those results in near real time, right? To make this amazing tool efficient and accessible for any researcher with a great idea. So naturally, everyone's eyes turn to AI. This is it. This is the solution. The promise was absolutely massive. But it turns out AI was missing a really critical ingredient.
The obvious idea that popped up was to create what's called an AI surrogate model. It sounds complicated, but the concept is actually pretty simple. You run one of those super slow, old-school simulations a bunch of times, you take all that data, and you feed it to an AI to train it to predict the results. Instead of waiting weeks, you could get an answer in seconds. Sounds like the perfect fix, right? Well, not so fast. Here's the problem with that data-only approach. The AI becomes an incredible memorizer, but a really bad problem solver. It can accurately predict a scenario it has seen before, but if you change just one variable, a slightly different wing design, a new airflow condition, the whole thing often just breaks. It doesn't truly understand the physics, it's just copying the homework it was fed.
And that really is the heart of the problem. A model trained only on data is severely limited in how it can be used. It lacks what scientists call generalizability, the ability to apply what it learned to new, unseen situations. And why? Because it never actually learned the rules. It never learned the laws of physics.
Okay, so this is where the whole story pivots. This is where it gets really, really cool. NVIDIA looked at this problem, at this missing piece of the puzzle, and they came up with something that changes everything.
It's called PhysicsNeMo. And the secret sauce here isn't just a smarter AI model. No, it's the entire platform. And what it does is fundamentally different. It doesn't just look at data. It fuses that data with the actual laws of physics.
So what exactly is PhysicsNeMo? Well, it's an open-source AI physics platform. But the real magic, the true innovation, is that it combines simulation data with domain knowledge. So instead of just showing the AI a bunch of examples and saying, figure it out, you're also giving it the textbook. You're giving it the actual physics equations. That is the game changer. And because it's open source and built to scale, NVIDIA is basically handing this incredibly powerful tool to scientists and engineers everywhere.
Okay, so that all sounds great in theory, right? But what does this actually look like in the real world? What can it do? Let's check out a pretty mind-blowing example.
4,000 times. Seriously, just let that number sink in for a second. What on earth could possibly be 4,000 times faster?
Well, the answer is simulating the ridiculously complex airflow around a wind turbine. A company called Siemens Gamesa used PhysicsNeMo to train an AI model that does this, 4,000 times faster than their old methods. You know what that means? It means they can test a wild number of different designs for wind farms to find the absolute most efficient layout. This is a massive accelerator for green energy.
And it is absolutely not just about energy. This stuff is popping up everywhere. Climate scientists, they're using it to power generative AI for way better weather forecasts. In medicine, people are using it to simulate blood flow in the human body, which could lead to totally personalized treatments for things like heart disease. This tech is starting to touch almost every major scientific field you can think of.
So, when you put all this together, it's pretty clear what's happening.
We are stepping into a brand new era for science and engineering, and it's being powered by this incredible fusion of AI and the fundamental laws of physics.
And this really gets to the core mission behind the whole PhysicsNeMo project. The point isn't just to build some super niche tool for a few experts. The goal is to make this kind of powerful AI accessible to every engineer, to every scientist out there, so they can start solving the world's biggest and most complex problems.
So if there's one thing to take away from all this, it's this. PhysicsNeMo isn't just about making simulations faster. That's cool, but it's bigger than that. This is about changing how science itself is done. I mean, think about it. When you can test 1,000 new ideas in the time it used to take you to test just one, you don't just get faster answers. You start asking bigger, bolder questions. Questions you never thought you could even try to answer before. You're literally hitting the fast-forward button on innovation itself.
And that really just leaves us with one final, kind of thrilling question to think about. What happens, what do we discover, when we can simulate pretty much anything almost instantly? What once impossible problems are suddenly on the table? That's the future that tools like PhysicsNeMo are starting to unlock. Thanks for watching.